minus e to negative x divided by 2. This one is the same but with plus. And this one, of course, is this over this, and so on and so forth. So hyperbolic sine over hyperbolic cosine. And now this prime is cosine hyperbolic, and this one is positive, and this one is secant squared. And of course, we have the other ones. Implicit differentiation, we discussed implicit differentiation. When the function is not given to us and we cannot solve the equation, then we have to differentiate implicitly. So please remember the formula. This is 1 over the square root of 1 minus x squared. This one is the same, but with minus in front. And this one is 1 over 1 plus x squared. Arctangent, we graphed this function before, but let me graph it again. It has two horizontal asymptotes. This is y equals pi over 2, and this is y equals negative pi over 2. So this is a very important function. You're going to see it a lot. So here's the graph. So this is the graph of tangent inverse or arc tangent x. Same thing. So please remember the two horizontal asymptotes. Why? Because it's the inverse of the tangent, which has two vertical asymptotes, x equals negative pi over 2 and x equals pi over 2. Okay, natural log x prime, as we know, it's 1 over x. If it's a function, is 1 over the function times the function prime. And the same, these are the same, but the denominator has to have a natural log a. If it's e, it doesn't have it because it's 1. So these are the same, but it's base a. And this is the same with this one. So this is f, but natural log a times f prime. So these are the same. These are the same. The only difference is the natural log a, which otherwise would not be there because natural log e is 1. But we don't have e, we have a. Okay, and now let's start with any questions you may have. Anything from WebAssign, from anything, before we continue with 3.6. Anything you need help with?
I have one from WebAssign.
Yes, I'm ready. Thank you.
So it's y equals the quantity of x squared plus 4 divided by x squared minus 4, all to the power of 6.
Like this?
It just has, within one set of parentheses, it has a numerator and a denominator, but that'll work too. So like within the original set of parentheses that you had, it has x squared plus 4 over x squared minus 4.
So is it like this?
Yes, to the 6th power, yes.
Perfect. Okay, good. So this is our y. So we're asked to find dy over dx, correct? Or y prime. Okay, perfect. So y prime. So I have a function to power 6. I have to bring down 6, subtract 1 from 6, times the inner function prime. Since it's a ratio, the denominator is simply squared. And now, the top prime, 2x, times the denominator, minus the top, times the denominator prime. Is this preliminary step okay?
Yes.
Okay, perfect. The next step, of course, I will factor out 2x. So 2x times 6x will be 12x. X squared plus 4 over x squared minus 4 to the 5th power times x squared minus 4 minus x squared minus 4 divided by x squared minus 4 squared. Luckily, these two go away. negative 4 times 12x becomes, I'm sorry, negative 8. Negative 8 times 12x is negative 96x divided by this x squared minus 4 squared. Now, there is no need to do this, but it's common sense, I would say. I will write x squared plus 4 to the 5th power and x squared minus 4 to the 5th power, because I know I can multiply the factors in the denominator without expanding, of course. 96x, x squared plus 4 to the 5th, and this is to the 7th, because they are the same. Copy the base and add the exponents. So let me calculate my numbers again. Negative 8, so that's 6, yes, and 1. I think I'm okay. So negative 96x at the top with x squared plus 4 to the 5th power, and the denominator with x squared minus 4 to the 7th power. Is this clear?
Yes.
Every step?
Yeah, I'm looking back over what I wrote down. I think so. Pulled out the 2x.
Yes, I will
Simplify
never
those.
distribute. I will never distribute if I can simplify it. And factoring is always my best friend.
Yeah, I think that's good.
Don't take it off the screen yet, please.
Oh, absolutely not. And also, I will post it, as you know. Very good.
Thank you.
Very good question. Thank you. Other questions? Anyone else wants to work on any problem? Any problem? Any questions? Please remember to finish all WebAssign before test 2. You will not be able to take test 2 at all without finishing every assignment in chapter 3. Please. Yes, Amanda, you had another question?
Is that finishing 100% or just 70%?
70 is good for me.
Okay, thank you.
It doesn't mean that I will transfer 100% if a student finishes
Right.
70. Okay, but 70% is good enough, and you can go back later. If you want to raise that, that's fine too. I will correct the grade later. With pleasure.
Thank you.
Thank you. Other questions for me? Anyone else? Okay, if anything pops up, please stop me anytime. As we discussed, natural log x prime is 1 over x. But I would like to show something else. Let's take a look at the function, the natural log of the absolute value of x. So this is our f of x. As you know, when we have an absolute value in a function, we have to simplify it without the absolute value. Can anyone remind us what does the absolute value equal to? Please.
When x is like when x is like greater than 0 or something like that, or less than 0.
It cannot be
and-
less. It cannot be greater than
x.
or equal to or less.
Yeah.
Okay.
And it's like negative x is, and then if x is like greater than 0 or
It-
less than 0.
Yes. We already have greater than 0 here, right? It has to be the other one. Awesome. So therefore, there are two options here. Natural log x. And I cannot include 0 because this 0 doesn't belong there. It's okay here, but not here, inside the natural log. Or natural log of negative x for x less than 0. Perfect. That's all I needed for now. Now, of course, oh, what is this? Of course, I want to differentiate this function, which means I have to differentiate these. To differentiate this, I have to differentiate these. Okay, so let's do that together. Okay. That's my page 3. So, natural log x, prime will be. Can anyone give us the derivative of natural log? It's right here. You have to say immediately.
1 over x.
Thank you so much. for x greater than 0. Now this is natural log of a function. It's not plain x, so this is a function. You can say, but x is a function too. Yes, but x prime is 1. Negative x prime is not 1. So this becomes a function composition. Can anyone give us the derivative of this? And I will put it here. Okay, here's the formula.
One over the absolute value of x.
We don't have the absolute value. We are differentiating this.
Oh, that, okay. 1 over negative x.
Excellent. Times the inner function prime.
Negative 1.
That's it. Well, it turns out to be 1 over x as well.
Right.
So this is x less than 0. So please remember, natural log of 1 over x prime is also 1 over x. Of course, x cannot be 0. So these are the same. If it's an absolute
Daddy
value,
bonus?
say it again. Say it again, Talia. I guess you're not muted or something. Okay.
I did not mean to. I'm sorry.
No, that's okay. That's I thought you had a question. That's why I wanted to stop and answer the question. Okay, so this and this are the same. Of course, this is also x not equal 0, of course. And in this particular case, it has to be strictly positive. But here, this is already fulfilled. Perfect. Now, I want to talk about something that we have not seen before. This is completely new. And I would like to open, I'm sharing my screen. I'm going to 3. I'm going to 3.6. We went all through all of these. Okay, here it is. I would like us to choose from problems 49 through 56. 49 through 56. If not, I will choose.
53.
Okay, perfect. So let's look at 53. And in 53, we have y equals cosine x raised to power x. Perfect. Okay. So notice that this is completely new. We have never seen this before. How come? Yes, we've seen a function to power n, number. We've seen the square root of a function, which is still a number, 1/2. But we have never seen a function raised to another function. This is function f of x. This is function g of x. This is totally new. So the question is, how do I differentiate this? And the answer is no rule. There is no rule for such a differentiation. What we need to do is apply. You can say there is a rule. I meant a differentiation rule. It's a two-step procedure, basically. Not a rule, but a two-step procedure. We have to apply log and then differentiate. So when I say no rule, I mean there is no specific differentiation rule. If you want to say, but there is a rule, we have to apply log first and then step 2, differentiate. So this is called logarithmic differentiation, and of course we're going to differentiate implicitly. So it's a combination of two things. First we're applying log, and then we're applying implicit differentiation. And this is called logarithmic differentiation. So coming back to our example, our first step, we have y equals cosine x raised to power x. We have to apply natural log to both sides. So in step 2, I have natural log y equals natural log of cosine x raised to power x. Can anyone tell us what happens next? What do I have to do next? Anyone remembers the property of the logs that we discussed that needs to be applied here? Any property? Anyone, please?
Would that be x ln cosine? X?
Exactly. We have to use the power rule. Excellent. Thank you so much. So we have natural log equals x multiplied by natural log of cosine x. Perfect. So first step, I shouldn't even call this first step, but anyway, it's the first line. I have to write the function as is. Step 2, I apply natural log, and then I apply one of the properties of natural log. And now in step 3, I will differentiate. Implicitly, of course. So 3, diff implicitly. Okay, so let's do that. So we're differentiating the left-hand side, and we're differentiating the right-hand side. Can anyone differentiate the left-hand side for us? Just the left-hand side.
It's 1 over y.
Okay, y is a function of x.
dx.
dy over dx.
Times the inner function prime. Very good, awesome. And now let's differentiate the right-hand side. What rule applies here?
The product rule.
Awesome, very good. So let's apply the product rule. The first function prime is?
1.
Very good. Natural log of cosine x plus x times. Now we're differentiating this. How do we do it?
Yeah, 1 over cosine x times negative sine.
Excellent. Great job. So the left-hand side is 1 over y times dy over dx. Only one equal symbol. This is an equation. Do not continue to the sides, and we cannot do that here. Do not write the equal symbol and continue. It's an equation. Every step of the way has one left-hand side, one equal symbol, and one right-hand side. Notice that I went back to the next line and copied the left-hand side. Do not go to the sides. Equals natural log of cosine x minus x sine over cosine is tangent x. We are solving for this. What should I do to both sides? So we differentiate implicitly. So let's say step 4, solve for dy over dx. What do we do to both sides to solve for dy over dx?
Multiply both sides by y.
Exactly. Instead of y, I'm going to write cosine x to power x because that's the y that we selected. Natural log of cosine x minus x tangent x. This is it. I could have put y in here, but I have to replace the y by what y equals to. You don't have to do anything else. You don't have to distribute, nothing. This is it. So again, why are we using logarithmic differentiation? Because I have no rule for a function to another function. You cannot use this rule. Please do not bring G down and subtract 1 from G and no rule is applicable here. A combination of 2 steps, right? Step 1, apply log. Step 2, differentiate implicitly. Good. Okay, I think we should,
Hold on, I have a
yes, please. Yes.
Okay, so to go from the bottom of step 3 to step 4, we multiply both sides by y.
Because it's 1 over y.
Yes, I get that. But then in step 4, you took what was at the bottom of 3, and it doesn't say times y, it says times cosine x to the power of x.
Right.
Oh, because that's back what we were given. Okay, got it.
So that's what I said. I could put here y.
Gotcha. Okay.
But then I have to replace it by what y equals to.
Gotcha. Okay, thank you.
Thank you. Very good. Let's see if we want to select another.